Hello everyone, welcome to our channel Sadhguru Excellence Academy. Today we are going to learn chapter number 2 of algebra of standard 10, that is quadratic equation. So in this chapter we are going to learn first what is an equation, then we will come to how to write an equation, after that quadratic equation, and then general form of the equation. So in today's video, after this we are going to cover practice set 2.1. So in today's video we are going to cover all these topics. Fine. So let's start. What is an equation? We all are aware of polynomials, right? Polynomials can be evaluated with some constant terms or with another polynomial. For example, 2x square plus 3x plus 5. This is an expression, right? But if we are evaluating this expression with some other term, let's say 0, then here the whole expression over here, it gets converted into an equation. So with this equal to sign, equation comes into being. So here this expression, this because of this equal sign gets converted into equation. Some other examples of equation are 2x plus 5 equals to 3, or you can say 0. 3x cube plus 4x square plus 5x plus 3 equal to 0. Alright. So next, how to write an equation? Can you see this pattern? I mean, here we have x power 3, x power 2, x power 1, and here there is no x, it means x power 0, because anything raised to 0 is nothing but 1. So while writing an equation we have to follow this pattern. How to write an equation? Suppose let's write an equation. If I am writing an equation, suppose 4x square, so very next to it there must be a term having any constant coefficient but having power on x which should be less than the preceding one. Okay, after this it will have something constant, then x power 0 which is equals to 0. X power 0 means it is obviously equals to 1. Alright, so this is how to write an equation. After this, what is a quadratic equation? Let us talk about quadratic equation. How quadratic equation looks like, and which equation can be called as quadratic equation. Suppose we have an equation 4x square plus 3x plus 4 equals to 0. So let us know about degree of the equation. So what is degree of the equation? Degree is the highest power of the variable in a given equation. So here the variable is x, but what is the highest power on the variable x? Here it is 1, here it is 2. So highest is 2, right? So if the highest power of the variable in the given equation is equals to 2, that is the degree of the given equation is 2, so it is nothing but the quadratic equation. It is called as quadratic equation. So if degree equals to 2, then the given equation is quadratic equation, right? Okay. Can this be a quadratic equation? If anybody says, is it a quadratic equation? Obviously, yes, it is. Why it is a quadratic equation? Because it has the degree 2. The given equation has degree 2, that is why it can be called as equation. Okay. So, how to identify that the given equation is a quadratic equation? First thing, we have to check its degree. Degree must be equals to 2. Second thing, if in an equation, in a quadratic equation, the variable with highest power have the constant term 0. Constant term means this is the variable with highest power, that is 2. But if this coefficient is 0, instead of 4, if it is 0, then it is not a quadratic equation. In any quadratic equation, if coefficient of x square term is 0, then it is not a quadratic equation. So for being in quadratic equation, here the term x square must have coefficient non-zero. Next, what is general form of quadratic equation? So if you observe this equation, right, you will get here this is something constant, then variable having power 2, then another constant, and this constant can be anything, right? Then again variable with power 1, then another constant, and this constant can also be anything. Okay, so we can generalize this pattern, this format. How? For general form of quadratic equation, we can have ax square plus bx plus c equals to 0, where a can be anything, b can be anything, c can be anything, means a, b, c are constants, right? Yes, so here it can be 2, 3, 4, 5, 6, anything, 7, 8, 9, 10, 11, anything, constant terms. So this is the general form of quadratic equation, and what I just mentioned over here, for a quadratic equation, a cannot be equals to 0. If a is equals to 0, then it is not a quadratic equation. Alright? Okay. In practice set 2.1, if you see the first question in your textbook, it is write any two quadratic equation. The first question of your practice set is write any two quadratic equation. So can you write any two quadratic equation? Just looking at the general form, ax square plus bx plus c equals to 0, where a cannot be equals to 0 and a, b, c are constants. Obviously we can write many quadratic equations, right? For example, 2x square plus b can be 0, right? So 0x plus c equals to 0. So this is the quadratic equation. You can write this as 2x square plus 3 equals to 0. So this term also can be 0, you know. 3x square plus 0x plus 0 equal to 0. So you can write it as 3x square equal to 0. This is also a quadratic equation. Again, but this term cannot be equal to 0, right? So 4x square plus 5x plus 3 equal to 0. So one quadratic equation, that is this one, this one, this one. So we have written 3 quadratic equations. Second question is, this was the question number 1. Question 1. And what is the second question? Second question is, decide which of the following are quadratic equation. So we have to identify which are quadratic equation or not. First question is x square plus 5x minus 2 equals to 0. X square plus 5x minus 2 equals to 0. Question 2, sub question first. Is it a quadratic equation? First we will check degree. Yes, degree of the given equation is 2, and also the coefficient of this term is non-zero, right? So it is 1. So here, since degree of given equation is 2, therefore it is a quadratic equation. All right. Now second question is y square equals to 5y minus 10. Y square equals to 5y minus 10. So first we will write this equation in the general form of quadratic equation. So first should be this, then a power having 1. So this will come this side and it will become minus 1. and this minus sign will become positive, and on right hand side there is nothing left, so it is 0. So this is the general form. Okay, so what you observe, what is the degree of the given equation? Yes, degree of the given equation is degree of given equation is 2, therefore it is a quadratic equation. We can also see here this term we have coefficient which is non-zero, right? Except 0 it can be anything. Next question is y square plus 1 upon y equals to 2. Alright, y square plus 1 upon y equals to 2. Before converting into general form, we cannot identify whether it is quadratic equation or not. So first we have to convert this into general form. How to convert this in general form? Now we can multiply the whole term LHS and RHS by y, because we want to eliminate this y in the denominator. So multiplying both sides by y. Okay, so what will happen? This y square will become y cube plus this y will get cancelled, so it will become 1, and that is equals to 2y. Alright, so this y term should be before this term, so y cube plus 0y square minus 2y plus 1 equals to 0. I had already taught you that how to write an equation. So first y cube, then y square, then y power 0. Alright, but if you observe over here, the degree of the given equation is not equals to 2, it is equals to 3. Is it? Yes, the degree of the given equation is 3. So since degree of given equation is not equals to 2, therefore it is not a quadratic equation. Are you getting? Okay, fine. Next question is x plus 1 upon x equals to minus 2. Now question number 4. What is the question? X plus 1 upon x equals to minus 2. This is not in the form of the general form of quadratic equation. So what we have to do? We have to convert it into general form. So as we did in the previous question, we will do the same. What we will do? We'll multiply by x, because we want to eliminate this x as a denominator, right? So multiplying by x on both sides. So here it becomes x square plus x upon x, it becomes 1 equals to minus, it becomes 2x. Why? Because we multiply it by x. So now x, this term must come before this one, x square, this minus 2x becomes plus 2x, and plus 1 equals to 0. So now this is in the general form of quadratic equation, that is ax square plus bx plus c equals to 0. Now is it the quadratic equation? So what we have to check, whether its degree is 2 or not. So here the degree is 2. So therefore, since degree of given quadratic equation equals to 2, therefore it is a quadratic equation. Alright? Okay, now let's move on to fifth question. So this is the given question. Now we have to convert this first into its general form, then we have to check whether it is quadratic equation or not. So here there are two brackets, so we have to multiply these two brackets. So first m multiply by the whole bracket. We all know the tricks of multiplying, right? The m minus 5 equal to 0. So mm becomes m square minus 5m plus 2m minus 10 equals to 0. Like terms, 5m and 2m but here it is negative sign. So negative and positive becomes negative. So negative, and after subtracting we get 3m minus 10 equal to 0. So this is already in the general form of quadratic equation, alright, because here am square plus bm plus c equals to 0. Variable can be anything, x, y, z, am, and anything. So this is, here we have a degree 2. So since degree of given quadratic equation equals to 2, therefore degree of the given equation is 2. So therefore it is a quadratic equation. Alright, okay. Let's move to the sixth question. The question is m cube plus 3m square minus 2m equals to 3m cube. M cube plus 3m square minus 2 equals to 3m cube. Alright, so what we'll do, we'll bring this 3m cube here. So m cube minus 3m cube plus 3m square minus 2 equal to 0. So these are the like terms. So plus and minus becomes minus. So after subtracting we get this 2m cube plus 3m square minus 2 equals to 0. This is the standard form. But what is the degree of the given equation? Can you guess the degree? Yes, the degree is 3 over here. Since the degree of given equation is not equals to 2, therefore it is not a quadratic equation. So here the degree is not equals to 2, right? The degree is 3. So this cannot be a quadratic equation. So let's move on to the third question. The third question says, write the following equation in the form of its general form and write the values of a, b, c for each equation. So what you have to do, you have to write the given equation in the general form. General form is ax square plus bx plus c, and what are the values of a, b, c you have to state there. So let's do it. Pause. So we have to write in question 3, we have to write the given question in the general form, and general form is ax square plus bx plus c equal to 0, and we have to find out the values of a, b and c. Alright, so we can find by comparing with the general form. So first we'll write the question. The question is 2y equals to 10 minus y square. So they are saying that the given question is already in quadratic equation. We have to just write this equation in its general form, and we have to evaluate its a, b, c, that is the constant terms in this. So first write in the general form. So the general form is, bring y here, y plus 2y minus 10 equals to 0. This minus y comes, and here it becomes plus y square, and 2y as it is, and plus 10 it comes here, then it becomes minus 10. Alright, so we have got the general form of the given equation. So comparing it with general form, we get, what we'll get after comparing with general form, we will get a equals to 1, b equals to 2, and c is equals to minus 10. See how simple it is, right? Second question, we have x. So the second question is x minus 1 the whole square equals to 2x plus 3, right? Now we have to write in its standard form. So first this is a minus b the whole square. A minus b the whole square is nothing but the a square minus 2ab plus b square. So we have to write this bracket in this form. So it becomes x square minus 2x plus 1 equals to 2x plus 3. So this 2x will come this side. So x square minus 2x, and this plus 2x becomes minus 2x plus 1, and this plus 3 becomes minus 3 over here, equals to 0. So this becomes x square minus like terms, and minus minus becomes positive. So for x, so here plus minus minus, so minus 2 equal to 0. So comparing this equation with general form gives us the values of a, b, c. So comparing, again the same statement, comparing with ax square plus bx plus c equals to 0, we get a equals to, here it is 1, b equals to minus 4, and c equals to minus 2. Alright, so now we'll move to third question. Third question is x square plus 5x equals to minus x square plus 5x equals to minus 3 minus x. Okay, so let us solve this. First we'll convert this in the general form. So x square plus 5x, and we'll open the bracket, and this becomes minus, consider it as minus 1. So it becomes minus 3 plus x. So this x will come this side. So x square plus 5x, x comes here and becomes minus x, and this minus 3 comes here and becomes plus 3, which is equals to 0. So now therefore put therefore x square, these are the like terms, but plus minus becomes minus. So here it becomes 4x plus 3 equals to 0. Now again comparing with ax square plus bx plus c equals to 0, we get a equals to 1, b equals to 4, and c equals to 3. And here is the answer. Alright, so fourth question, 3m square equals to 2m square minus 9. 3m square equals to 2m square minus 9. So let us write in the general form. 3m square, this 2m square will come this side, becomes minus 2m square, this minus 9 will come this side and becomes plus 9 equals to 0. Sign changes when we move the terms across the equal to sign, right? So therefore these are the like terms, so plus and minus becomes minus, so remaining part is only m square plus 9 equals to 0. So we can write this m square plus 0m plus 9 equals to 0. Okay, so now it looks like the general form, right? Yeah, here's the general form. Where it is? Yeah, here is the general form. So it looks like the general form. So comparing with general form, comparing with ax square plus bx plus c equals to 0 gives us values a equals to 1, here 1, b equals to 0, and c equals to 9. So if any term is not there, it means it has the coefficient 0, right? If the c part is 0, so c becomes 0, b part is 0, but a cannot be 0, right? As we all know, the definition of quadratic equation says in the quadratic equation a part cannot be 0. Okay, so next one is fifth one. We'll solve the fifth question. So question fifth is here. So first what we'll do, we'll write in the general form, and then we'll compare and obtain the values of a, b, c. So it will get multiplied, it becomes 3p plus 6p into p, it becomes 6p square equals to minus 5. We want to bring minus 5 this side, so this sign will change and minus 5 will become plus 5. So therefore 6p square plus 3p plus 5 equals to 0. Yeah, it looks like the general form. So comparing with general form, comparing with ax square plus bx plus c equal to 0, we get a equals to 6 over here, b equals to 3 and c equals to 5. Alright, moving to question number 6. First we'll write in the general form, and so here it becomes x square minus 9, this 13 will come this side and becomes minus 13. Yes, so x square like terms and minus minus becomes plus. Obviously we do the addition but the sign remains the same, so minus and becomes 22 equal to 0. So this can be written as x square plus 0x minus 22 equal to 0, right? So now this looks like the general form. So comparing with ax square plus bx plus c equal to 0, we get a equals to 1, b equals to 0 and c equals to minus 22. So here we finish with question number 3. So now we are going to learn roots of quadratic equation. So what are the roots? Let's take an example. Consider a linear equation 4x minus 8 equals to 0. As we will solve this problem, 4x, this 8 will go that side, it becomes 8. So x equals to 8 upon 4 and x equals to 2. So for x equals to 2, for the value of x equals to 2, if you put here x equals to 2, so it becomes 0. How it becomes 0? 4 to the 8 minus 8 equals to 0. So left hand side becomes equal to right hand side. So here this is the root of the given linear equation. But for quadratic equation, you observe that here it is the degree is 1, right? And number of roots are 1. But in quadratic equation, since the degree is 2, like this, x square plus 4x minus 3 equals to 0. Since the degree is 2, so we will have two values, x equals to a or b. We can have two values for which this left hand side of before equals to and the right hand side, they both become equal. Suppose this is 0, so after putting a and b in this equation, we will get the whole term 0. Okay, so these are the roots of given quadratic equation. So let us solve some problem. Let us check how to identify whether the given value of x is root or not. So here I will pick one question from question number 4. Given problem is x square plus 4x minus 5 equal to 0, and we have to check for the value of x equals to 1 and minus 1. For these two values, whether the given equation it is satisfied or not by these two values. So let us check. So what is the condition for checking? This left hand side must be equal to right hand side. This is the left hand side, this is the right hand side. After putting the value of x in the left hand side, it must be equal to whatever the value. It is not necessary that it will be always 0. It may be anything, right? So this LHS must be equal to RHS. So let us check for x equals to 1. So left hand side becomes, first of all, left hand side is x square plus 4x minus 5. So after putting this value, so it becomes 1 square plus 4 into 1 and minus 5. So 1 square is 1 plus 4 ones are 4 minus 5. So plus and plus becomes plus. So 5 minus 5, which is equal to 0, and it is this left hand side equal to 0, left hand side equals to 0, which is equal to right hand side. So since LHS equals to RHS, therefore x equals to 1 is root of given quadratic equation. Now let's check for x equals to minus 1. For x equals to minus 1, write down the LHS, that is equals to x square plus 4x minus 5 equal to, and this like that. Now put the value x equals to minus 1. So minus 1 the whole square plus 4 minus 1 minus 5. Minus 1 square square of any negative term becomes positive. So it means square is never negative. So it is 1. Minus and plus become minus. 4 1 ja 4 minus 5. Minus and minus adds up, and here it becomes minus 9. So it is minus 8, which is not equals to RHS. Which is not equals to RHS. So LHS is not equals to RHS because RHS was 0. And here we are getting LHS minus 8, which is not equals to 0. So left hand side is not equals to right hand side. Therefore, x equals to minus 1 is not a root of quadratic equation, of given quadratic equation. So it means this value x equals to minus 1 does not satisfy this equation, and hence it cannot be the solution of this quadratic equation. Okay. Now we'll see the question number 2. 2m square minus 5m. 2m square minus 5m. Two m square minus 5m equal to 0, and we have to check for the values 2 and 5 by 2. So let's check. First, for m equals to 2, LHS becomes, first write down the LHS. Okay, LHS means left hand side, and now putting the value m equals to 2. So wherever there is m, we have to put 2 instead. So 5, 2. 2 2s becomes, it becomes 4, 5 2s are 10. So it becomes 4 2s are 8 minus 10. So it becomes minus 2, which is not equals to right hand side. Right hand side is 0, right? So which is not equals to right hand side. So this LHS is not equals to RHS, and therefore m equals to 2 is not a root of given quadratic equation. All right. Now let's check for m equals to 5 by 2. So LHS becomes 2m square minus 5m. Now put the value 5 by 2 instead of m, 5 by 2. So it becomes 2. The square of 5 by 2 becomes 24 by 4 minus 25 by 2. 2 1s are 2 2s are. So we have 25 by 2 minus 25 by 2. So it is this, both the terms same but opposite sign. So it becomes 0, which is equals to RHS. So we have LHS equals to RHS. Therefore, m equals to 5 by 2 is a root of given quadratic equation. So here we are done with question number 4. Now in question number 5, if you see, the question is find k if x equals to 3 is root of equation. Okay, so we have an equation given there. What is the equation? The equation is kx square minus 10x plus 3 equals to 0. And they are saying x equals to 3 is root, and we have to find the value of k. So the given condition is x equals to 3 is the root of given quadratic equation. It means after putting x equals to 3 in the given equation, LHS must be equals to RHS, right? Yes. So since x equals to 3 is root of given quadratic equation, so it must satisfy the equation. All right, satisfy the equation. So it means LHS must be equals to RHS. So k times 3 the whole square minus 10 3 plus 3 must be equals to 0. So here 3, it becomes 9, k 9, and 30 plus 3 equals to 0. So 9k minus, it becomes 27 equals to 0. 27 will go that side. So minus 27 becomes 27 plus 27. and this k, here it is multiplied, it will go across the equal to sign, it becomes in division. So k equals to 3. So the value of k is 3. So question number 6 is very much similar to question number 5, and some hints has been given in the question number 6. So you have to just put the values and you can get the answer easily. So this is a homework for you, as it is an activity, so I will not do activity over here, and meet soon in the next video. In the next video I will be telling the ways to find out the different solutions, and we have different ways. So bye and do the homework.